This is lesson 9.4, parallel chords, congruent arcs, and the hat theorem. So, okay, so the next theorem that we got is if you have two chords that are parallel, what ends up happening is their intercepted arcs, or this AC and this BD, end up being congruent. So like if this is, say, 10, that would be 10, right? And so forth. So let's kind of just jump right to it. This is an easier kind of one. So looking at example 1, it says you're given circle O and that AB is parallel to DC. So right away when you see that, these two are going to end up being congruent. So that means that BC has to be 80. So if they want arc CD, all I have to do on this one is just 360 minus 80 minus 80 minus 60, and that would be my answer. So you end up getting that measure of arc CD, okay, is 140. Okay, so then for the next one. So again, they have it marked parallel. So they're also giving me in this one a central angle. So if the central angle is 40, its intercepted arc is also 40. So if this is 40, this has to be congruent to this side of 40 because of that theorem. So then I get x, same thing. I'm going to do 360 minus 40 minus 40 minus 160, and you get 120. So x in this case is just 120. Okay, perfect. So number 3. So given circle O, CD is a diameter, that's going to be important. AB is parallel to CD, so mark those parallel. So right away I know that these two arcs, intercepted arcs, are going to have the same degrees in them. So if AB is 80, they want us to find what CA is, so we'll call that X. Well, if this is an X, that's an X. So we know that these three arcs, because it's a diameter, are going to add up to be 180. So I know that X plus 80 equals 180. Or that 2X plus 80 is 180. Subtract 80 on both sides. 2X is 100, divide by 2, and you get 50. Okay, and that's going to be what CA is. It's just 50. Okay, so then if you guys turn the page, okay, this is the next theorem. Not a lot of questions with this, but it is important. So pretty much all you guys need to know is that if two chords are congruent, their intercepted arcs are going to be congruent. Okay, so pretty self-explanatory. Usually it looks like that, so most people can kind of reason this out without knowing that. So this is the only example I have for it. So if AB is parallel to CD, DE, the side, is congruent to CE. And then let's see, arc AB is 50, arc BC is 30. Find the measure of arc DE. So they want that. I'm going to call it an X. So first off, if we have two parallel chords, we know their intercepted arcs are the same. So this would be a 30. So then if these two chords are congruent, I know that their intercepted arcs are congruent. So then what I could do with this is I could just do 360 minus, let's see, I could do minus 50 minus 30 minus 30. So let's see, 360 minus 50 minus 30 minus 30 gives me 250. And then I could just half it. Sorry, it just hit the camera. Okay, then I could just half that. So half it, and I would get 125. Okay, so this would be 125, 125. So in this case, the measure of arc DE is 125, and that would be my final answer. Okay, and then the last theorem is called the hat theorem. So a lot of people remember this. I call him the creepy hat guy. Pretty much what you guys need to know is that if you have two tangents drawn, so two of them in there, so 1, 2, what ends up happening is they end up being congruent to each other, okay? So if you can remember the creepy hat guy, the two sides of the hat will always be congruent. So what that will do every time is it makes an isosceles triangle where these base angles are congruent, okay? So there's a lot of different types of ways they can ask this. So looking at this picture, sometimes they connect the hat not straight across like this. They connect it to the center. And if that would happen, you would actually get two congruent triangles by, if you kind of look at this picture, you would have hypotenuse leg, or you can think of it as side, 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 side. Okay, so that's just kind of what the theorem is. Okay, so then looking at some hat questions. So for the first one here, again, not meant to be hard. This is 15. It's going to equal it, okay? Super easy. So for number 5, you're going to set these two equal to each other. So x squared plus 5 would equal 21. So the easiest way to solve that is subtract 5 on both sides. X squared would equal 16, square root both sides, and you get 4. Okay, that's it for that one. And then this one. Now, if you notice, this is a little different. Okay, it's still got 2 tangents in there, but now they're connecting it to the center. So right away, I know that A is 12 because it's a radius. So A is 12. Then if I look by the hat theorem, if this is a tangent drawn from the same exterior point, I know that C would equal the same. It equals 16. So then the question is how do you find B? Well, we have 2 sides of a right triangle, so we can do Pythagorean theorem to find the missing side. So I can do 12 squared plus 16 squared equals B squared. And if I solve this I can actually add all together in my calculator. You get 400 is B squared, square root both sides, and you get that B would be 20. Okay, guys, so that's it for this lesson. Thanks.